So in 16.2, we learned about equivalence of mass and energy and how Einstein basically discovered that and confirmed his theory. In 16.3, we're going to look at the correspondence principle, which is basically how Einstein confirmed his theory and made sure that it agreed with past theories that had been made and didn't disagree with scientific theories that have already been confirmed. I just want to start off for 16.3 about what the correspondence principle actually says. The correspondence principle states that a new theory and an old theory must overlap and agree in the region where the results of the old theory have been fully verified. So in this video, we are going to compare Newton's theory that he originally had of the falling apple and the gravity to what Einstein created was the general relativity theory. And it's basically going to use the correspondence principle, and I'm going to explain a little bit about that. So essentially in this demonstration, the green represents the pull up from the tree, and the red represents the pull down from the apple, and it's going to compare Newton versus Einstein and how Einstein really used Newton's law and expanded upon it and almost made it better and more useful to us rather than Newton's law, which was just very basic. But they both were correct, and Einstein confirmed and made better of Newton's, therefore using the correspondence principle. Through my research on this subject, I noticed a common theme, and it was almost like people were saying that Newton's laws were almost obsolete because of Einstein's discoveries. But in all reality, Einstein's discoveries were just built off of Newton's laws, and that goes along with the correspondence principle that it wasn't new information; it was just more in-depth information. So no, it doesn't make it obsolete. It just makes it better. And the reason we still keep Newton's laws around is because they're easier to understand and they're more practical for day-to-day use and what we can really grasp our minds around. Okay, now I want to talk about special relativity. And special relativity holds for all speeds, but it's really only significant for speeds that are close to the speed of light or at the speed of light. And special relativity is really the base that Einstein used to create his theory of general relativity. So I just want to show a really short clip explaining that, and this professor does a really good job of that.
Patent office, and he's looking at devices to synchronize clocks. And the only way to synchronize two very distant clocks is to send a signal between the two of them, and that signal travels, at the speed of light, whether it's a light signal or any other electromagnetic wave. And there you've got this patent examiner saying, what if I caught up with that light wave? And so he does some thought experiments, and what he comes up with is the understanding that, oh, I get it. A light wave always travels at the same speed. The speed of light is always constant. But time is relative depending on your state of motion. And that's really just all the foundation of the special theory of relativity. That's all it is.
So in conclusion, 16.3 is really about the correspondence principle, in that when Einstein set out to create the special relativity theory, and then after that, using the special relativity theory to create his general relativity theory, which we will be learning about next, he used Newton's laws, and he didn't disprove them. He didn't make them wrong, and it doesn't make Newton's laws obsolete at all. He used them as a foundation for his laws. So the correspondence principle stating that they must overlap, and he made sure that they did, and that Newton's laws were proven correct, and that his new theories didn't prove them wrong. Otherwise, it would have made his theories incorrect. And that's basically what the correspondence principle is all about.